Welcome to the deep dive. This is where we take really dense source material and, well, we boil it down to the essentials you actually need, quickly.
Exactly. And today, our mission, your mission really, is all about preparing for the navigation part of your ATPL theory exams.
Yeah.
Air Transport Pilot License. Big one.
Yeah, laser focused. We've got a pile of notes here, excerpts covering everything from aeronautical charts, safety altitudes, altimetry corrections, and we're kind of basing this around a specific example chart.
That's right. It's the Jeppesen VFR Plus GPS chart for Germany, the ED6 1999 edition. It's a good reference point for the kind of details you'll encounter.
So this deep dive, it's really tailor-made for you listening. We're not just going to read definitions out loud. We're drilling down formulas, mnemonics, those key rules of thumb, things you absolutely need to nail those multiple choice questions.
And it's not just about the exam, is it? I mean, this stuff is the absolute bedrock of flight safety. Understanding projections, minimum altitudes, how your altimeter can, well, lie to you in certain conditions.
Yeah, non-negotiable.
Totally non-negotiable for practical flying. So our aim here is to make sure these concepts are really locked in for you, for good.
Okay, right. Let's get into it. Starting with the map itself. As we said, the source material uses this Jeppesen VFR chart, Germany 86, 1999. Now, whenever you get chart questions, you absolutely have to know the technical background. These details pop up all the time.
Definitely. And the first big technical piece is how you get the curved Earth onto a flat piece of paper accurately.
The projection?
Exactly.
Yeah.
This chart uses something called the Lambert Conformal Conic Projection.
Okay. Lambert Conformal Conic. Why that one? Why is it so important, especially for flying over places like Central Europe?
Well, the conformal bit is key. It means shapes of small areas are preserved, looks right locally.
Yeah.
And crucially for pilots, a straight line drawn on this chart is a very close approximation of a great circle route.
The shortest distance.
The shortest distance is really good for mid-latitudes, minimizing scale distortion over wide east-west areas. Much better than, say, a basic Mercator if you're flying a long way, or need true great circle tracks.
Gotcha. And the specific details for this projection? You said they're exam gold.
Absolutely. You need to remember how the imaginary cone sort of touches the Earth model. For this chart, the standard parallels are N37 degrees and N65 degrees. Remember those numbers? N37, N65.
Standard parallels, N37, N65. Why those specific lines?
Those are the latitudes where the map scale is perfectly accurate. By picking two, they minimize the scale error across the whole chart area between them. So your measurements, distance, position, they stay as accurate as possible where you're actually flying.
Makes sense. Okay, beyond projection, what else? Scale and units. Standard VFR chart scales.
Bone to 500,000.
Okay.
And 1,500,000 to lower.
And units. This is a classic trap, isn't it?
It really is. Distances, yeah, often nautical miles, but elevations on these charts. Always in feet. You have to watch that.
Feet for elevation. Got it.
Yeah.
Now, operational use. The rules change when you cross borders, right? The VFR flight level limits.
They do. Our source material points this out. Like, VFR might be okay below flight level 100 in Germany, but hop over to Austria, it jumps to FL 125, Switzerland FL 150.
So you can't just assume.
Never assume. You've always got to check the local rules, the transition altitude, transition level, especially before crossing an FIR boundary. The exam expects you to know that these variations are normal. It's regulation, not a chart mistake.
Right. Okay, shifting gears slightly. Coordinates. How we define a point in space. There's a global standard now.
Yes, thankfully. It's the World Geodetic System of 1984. Everyone just calls it WGS 84.
WGS 84. And why is that so important for someone studying for their ATPL?
Well, before WGS 84, different places use different local datums, different models of the Earth. So a position from an old VOR might not perfectly match your GPS. WGS 84 fixes that. It's the single reference for everything. Meaning all the critical points you navigate by. VFR, reporting points, aerodromes, radio NAVAIDs like VORs and NDBs. They must be defined using WGS 84 coordinates.
Okay, so that ensures consistency. Like the example given, Stuttgart NDB is N48 degrees.
All right. Many thanks for listening to this free part of the ATPL Theory podcast. If you want to continue learning and access the full comprehensive guide, go to my Patreon at patreon.com/ATPLtheory or my Hero at herohero.co/ATPL. That is patreon.com/ATPLtheory or herohero.co/ATPL. Wishing you all the best